Okay, hello everybody. Uh, this is Dr. Patugi, uh, CST 750 professor, and I'm here today to answer the sample questions series 1 that I've uploaded on Blackboard for your reference to make you familiarize with the type of questions and style of questions that you may see in the exam 1. Exam 1 will be available for you starting from tomorrow 8 a.m. until Friday 8 p.m. Eastern Time. Eastern Time. I state that that's Eastern Time. Please make sure that, because I know that we have some students attending the class from California and other Western states. Please make sure that all the timings are Eastern Time. Anyhow, I am recording this meeting so that I can upload it on Blackboard as well as the solution file, so that for those of you that you haven't had time or you might be busy with other stuff, you've not able to attend this, you can later watch this video before start attempting your uh, actual exam. And in terms of the style and number of questions and difficulty of questions, it's gonna be just exact same thing. Basically questions are, I would say, they're easy, and for you as a smarter student, I'm sure that you all will do a great thing. So without any further ado, let's get started with the questions. So I have shared my screen with you. I hope you see that. Otherwise, please let me know, Shelley. So here you see the questions. The order of questions here might be a little bit different than what you see in Blackboard. Doesn't matter, but let's get started with the multiple choice question. The first question is a multiple choice question that says which of the following statement is not correct. So this is the term that I've bolded, it is not correct, because sometimes I ask for what is not correct, and for some other cases I may ask for what is correct. So that's why I bolded, to make sure that you kind of pay enough attention to what the question is asking, and you're not gonna lose any score because of just me playing with that. That's not just to, that's not the intention of the question. So which of the following items or statement is not correct? Let's get started. Number A says ALU register bank and control unit are three major components of every processor. Okay, this seems to be correct because we have talked about this in the class, and I told you that uh, these three are the major three components of a processor. So let's go forward. Number B says CPU I/O interactions are very similar to CPU memory interactions. So this seems not correct, but let's go and check C and D, and then we'll get back to this if this is an actual answer. Item C says interrupts help improve the performance of computer systems by saving CPU time. Yeah, that's correct. That's what we exactly said for interrupts. Interrupts basically, they save CPU time and they allow CPU to take care of what is uh, taken care of now. And then whenever the I/O is ready, whenever the data is processed by I/O and data is ready to accept new data, or whenever I/O has produced data, it interrupts the CPU so that the CPU's time is not gonna waste it. So this item is correct. Item D says, in a time-sharing operating system, multiple processes are on the run at a time. Again, this is correct. So we get back to number B. Let's read it again and give it a second kind of thought and make our final decision. So CPU-IO interactions are very similar to CPU memory. In fact, it's actually opposite. If you remember, we had a slide, and in that slide, I completely talked about the differences between CPU-IO versus CPU memory. We said that CPU-IO is very slow, CPU memory is very fast. CPU-IO in terms of speed, second difference is that it's slow, but at the same time, it's very diverse. You have IOs like keyboard, which are very slow, 1 key per second. And also you have some IOs like this, which are very fast. So although they're altogether, they're very slower than memory, but even in themselves, there is a big variation in a speed. In terms of variation, again, memories are mostly the same thing, but IOs, they might be very different. IOs sometimes are electromechanical devices, but memories are not. And there are many differences between CPU I/O, CPU memory. So this item is the answer to this question. Is there any question about this?
No, I'm clear on that.
Okay. So free response, or let's first go over the multiple choices and then I get back to free response question. Multiple choice 2, which item is correct? Okay, item A says, among security functional requirements mentioned by FIPS 200, some might not be applicable on some computer systems. This seems to be correct. This seems to be correct because, yeah, we mentioned a number of security requirements, functional requirements, like, for example, let's say access control. Access control might not be applicable at some systems. Or we said, for example, uh, incident response plans. Incident response meaning that when some incident happens and the system is broken into, what should we do now? So that's, again, might not be the case for every system because um, you might not have that plan in place. That's mostly plans that organizations put in, not, for example, humans, but or individuals with a single PC or with a device. Or again, authentication, or for example, access control. If you have a computer with only single user, access control here may not make a very good sense. So this item seems to be correct. Let's go to B. B says, for the sake of performance, security checks don't have to be repeated every time. Okay, this is of course a wrong statement. We said that the security checks, like for example, authentication or username password checking, whatever, they should happen every single time. It's not like that we say, okay, this user was authenticated 5 minutes ago or 30 seconds ago, just let them pass. We don't need to ask his password. No, it should be checked every single time. So of course, B is incorrect. C says it would be very helpful if our security mechanism take back of each other so that if one fails, the system is still protected. So this is, if you remember, this is something that we called it layered security or layered protection, and the layered protection refers to this. It says that you would be better to have a various layers of protection mechanisms so that uh, so that you can have your system protected if one of the things fails. So in that case, yes, go ahead, Shell.
Hey, so this was the question that I emailed you about.
Mm.
Part or choice C. I wasn't sure if there was a typo because just reading it didn't make sense and it threw me off. It says it would be very helpful if our security mechanisms take back of each other. The part where it says take back of each other didn't make sense to me. So I wasn't sure if that's supposed to say talk back to each other. So I
Uh,
probably got this one wrong because I didn't understand C how
okay,
it was.
let me go to here. If you remember, this is the principle that I'm talking about. We said layering,
Okay.
and it's kind of a security principle, which says it's good to practice it. And what it says is that by the use of multiple overlapping protection approaches, multiple overlapping protection. Overlapping here means that, for example, you have, let's say, authentication, and the user, once the user want to get into the system, the user is asked for username and password. Okay, that's something that we rely on. However, after you enter your password, the system sends you a code, which is the second factor of authentication. So it basically, although your password, your username is protected by a password, but if because of any reason your password is broken and I'm an attacker and I have your password and I enter your username and password, it still cannot enter to that system and cannot steal your information. Why? Because there is another layer that kind of protects this failed layer, and that's second authentication factor, which is going to be sent texted to your cell phone. So when we say overlapping, means that they're basically helping each other. They're taking back of each other. So that if the first protection mechanism, whatever it is, if that one failed, the second one to some extent protects us against that thing. Is that clear now?
Yes. So in this case, the correct answer is D, because A and C are correct.
Yes, correct.
Okay.
Correct. So that oh, I'm sorry. I guess my screen wasn't the way I wanted to be shared. Let me reshare my screen. Yeah, this is a. Do you see my screen now? My entire screen, and you
Yes.
see the yeah. This is the slide that I was talking about. This is the slide that when I kind of started answering your question, I brought this slide, but I didn't notice that the screen wasn't shared. So this is the security principle that I referred to, saying that okay, we have multiple overlapping, and here overlapping means that they take care of each other to some extent. Of course, they are not replacement of each other, because if they're replacement means that they you have redundant thing, but they to some extent they help each other, and that's why I agree with you that this term is a little bit kind of in terms of wording is different, but yeah, that was intentional because I want to make sure that you understand what are meant, what are mentioned in the slides. It's not like that you just memorize them. So when here we say that they're overlapping protection between them, it means that they basically take care of each other. They back each other. Are we good to go to the next question?
Yes, thank you.
Yeah, so in that case, the correct answer is item D, that says B and C are correct. A, of course, is not correct. So let's go to the multiple choice 3. Okay. Yeah, the correct answer is A and C. A correct, I explained. C correct, B is not correct, and then the item that you should pick for this question is item D. Multiple choice question 3 asks about a situation, and it asks about to determine what type of situation it is, what type of malware is this. And the situation is this: the attacker has sent you an email with the URL of the website that offers you a good price for a given product. The website is known and legit. However, the attacker has defined a transparent layer so that you click on that layer to pay. However, at the same time, your click is also considered that you're kind of giving them permission to charge you for $10 donation as well. So what type of malware this attacker is using? So so the answer is here, of course, we are being referred to this page by that URL which is sent to us. So it seems to be a type of phishing attack. However, that's not the end of the story. We talked about another type of malware. We called it clickjacking, so that you click on something, but your click is either means something else to system, or is used for a different reason as well, or for different purpose as well. So this situation that here we are kind of dealing with. It's a combination of phishing, that we receive that email with that URL, blah, blah, and also clickjacking, that our click is on, for example, on buying one product or item is also considered as permission for something else. So it's a combination of phishing and clickjacking. So the correct answer to this question is item D again, which is combination of A and C. The answer is similar to that one, but of course, for a very different reason. Any question?
No, I'm clear.
Okay. Multiple choice 4, it says which statement is correct. And here, let's read the items and then talk about them. Item A says there are simple countermeasures for botnet that communicate with the command and control server with a static address or a fixed address. Okay, this seems to be correct because if you remember, we said that for those botnets or network of bots that they're using a static IP address for their CNC server, the moment the system or the security engineer identify that server, they can just tag to that server and disconnect that server or try to blacklist that server, something like that. So this seems to be correct, but let's go forward now. Item B says the common payload of spyware malware is information theft that compromises the integrity of the victim system. Okay, the first part correct. However, the thing that here makes me saying that this statement is incorrect is that information stealing is not an example of integrity violation. It's a case of confidentiality violation or loss of confidentiality. So item B is not correct. Item B says a hacker needs to put time and effort to implement a backdoor. So what was the backdoor? To answer this question, we need to recall the definition of backdoor. Backdoor was the case that I'm the developer of a system and I develop a code. That code, it has some features to help me easier debug that code. For example, when I run the code, instead of, for example, entering, let's say, 100 different inputs, I enter, let's say, star, and then it jumps to somewhere else in the code. So it bypasses some parts of the code so that debugging is easier for me as a developer. So, and later that kind of feature or backdoor is used or can be used by the attacker or adversary for security, for some sort of attacks. So having that said, attacker is not the person who develops the backdoor. Basically, the backdoors are developed by the system developer. The attacker is attacker here just needs to find and identify the backdoors and just exploit them. So that item, having that said, it means that item C is also not correct because basically hacker or attacker is not the person who implements it. It is the person who identifies it and just use it. And item D says, as malware is mostly compromised of software program, it cannot physically damage. There is no physical damage. Okay, that's the mice of or the wrong belief that the malwares, viruses, worms, they cannot physically damage your system. So that's not correct. I gave you an examples in the course. So items B, C, D, incorrect. The only item correct is item A. So the answer to this question is item A. Okay, we are done with multiple choices. Let's get back to if there is any question. Is there any question about multiple choice 4?
Not for me.
Okay, great. So let's get back to free response questions. And I'm gonna start with free response 1, which says, briefly explain how the CPU helps the operating system in making a safe transition between the user and operating system mode. So I explained in the class that once you have a operating system in a time sharing operating system, you might have multiple processes, and this is the operating system that intervenes and takes the CPU back and gives the CPU to the next process for execution and making progress toward finishing that. Excuse me. Okay. Yeah, I was saying that this is a CPU doing this. And again, I'm sorry, this is someone's calling me. I'm sorry about it. I had to take that call because I knew that probably they call again. Anyhow, I was saying that yeah, this is the operating system making that thing happens, transitioning between different processes in a in a time sharing environment. However, now the question is how CPU helps that happen. And in the class, I mentioned that CPU might have some features that facilitate that transition or make that transition safer for operating system. And I named a number. I am gonna give you here two numbers. One is, for example, timers, that CPU has some timers so that, for example, they count for, let's say, 1 millisecond, and whenever that 1 millisecond is over, the CPU automatically is being taken from the current process and is gonna be back to the operating system. So timers are one can be one answer to this question, and the other answer is something that we call it mode beat. There is a single bit in CPU, which is a hardware single bit that shows what's the current mode of the system. Is the system, entire system, including CPU and operating system and whatever, is it working on the user mode or kernel mode? And whenever CPU is gonna take it back and give it back to the operating system, it goes under the kernel mode so that everything, basically the operating system has access to everything needed. And whenever the this operating system is going to uh, give the CPU to one of the processes or applications, it puts it in the user mode. So it basically restricts that user code to not to have access to anything that the operating system has access. So these are two examples, timers and mode bits, that they help from the CPU side, they help the operating system to keep the entire system, including the operating system, safer and more secure. So if you point to one of them, that's the answer to this question. You don't have to point to two. Even one is enough for this question, and you can take the entire 15 points by adding one and a short explanations, of course. So free response 2, it says briefly explain the vulnerability, threat, and attack sequence. So we talked about it kind of very clearly in the class. And we said that vulnerability or exploit is any weakness in computer system, any type of weakness or imperfection that can be used for triggering a threat. That's something that we call it vulnerability. Of course, we have this slide here. Yeah, we have this slide here that we clearly talk about vulnerability, threat, and attack. It is fine if you use this exact definition, but I'm trying to give you I'm trying to reword it so that, again, give you this idea that concept here is important. Don't think about that, okay, I'm just looking at the exact words or sequence of words. No, if you convey the concept, you can get the point. And we are flexible. So we said vulnerability is any exploit or imperfection or weakness in a computer system that can be used in order to trigger or initiate a threat. So what is a threat? Let me get back to the question. A threat, we define it as any situation or some circumstance or scenario or event at which there are potentials for an adversary to impact the security of assets that we have in our computer system. So any occasion, any situation, any circumstance that there are potentials to at least one of those security pillars to be compromised. And then, of course, attack is once an adversary is actively using an exploit or a vulnerability, and he or she is actively trying to violate, and eventually he can violate, or he can compromise, or she can compromise one of our, at least one of our security pillars, including those 5 that we counted. So that's the attack, that vulnerability is being used, and we have been attacked so that we lost something. We lost either availability or integrity, confidentiality, accountability, or authenticity, one of these 5. So that's the what we had, and this is of course a very important concept about vulnerability, threat, and attack. And I wanted to show you that there is a chain in the videos. I talked about it a lot. Any question about it? Okay, free response 3, it says what are typical phases of operation of a virus or worm? Okay, we talked about it, and here I didn't even ask you to kind of explain it. I just asked to name it. And of course, you know that the phases are dormant phase. We started saying then dormant phase, and then triggered, and then propagation and execution. These are 4 phases that we know, we counted, we talked about them for both viruses and worms. So, and they're on the slide, so I've explained them. So, and again, here I only ask to name them. There is no need to explain them. Okay, and the last question here, okay, no, multiple choice 4. What is the difference between phishing and spear phishing? Okay, it's very, we talked about it in the class. Phishing, basically, in short, we can say that phishing is sent to a community of recipients or community of potential victims blindly, meaning that if I'm the attacker, I send it to a group of people. That group of people might be a group of users on the same network, or a group of user using the same specific application. So their IP might be different. They might be on different IPs or different locations. However, they're all using the same app, or those users, they have something in common, or I have the list of them. I have their email. That's the only commonality between them. However, I send that phishing email to all of them, and I have no intention to, for example, or I have no preference for one over the other. Any of them I can attack, that's fine, I'm good. Or as many as, if I can attack more or exploit or kind of break into more systems, I would be more happy. But there is no preference over the users from the attacker's point of view. However, in the spear phishing, the attacker kind of has a targeted victim, and the community of the victims, or it might be a single victim, or it might be a number of victims, that has been identified by the attacker ahead of time. And the entire email, which is going to kind of fool that person and persuade that person to click on something, is being modified, is being developed or designed in a way that persuade that person or those persons with a higher chance. So first off, we know the victim or victims, number 1, That's number one difference. Number two, the attacker puts some targeted information, including, for example, the name, or for example, something that the victim is sensitive about it. Put some targeted information in that email so that it kind of triggers the victim to click on that. So these are two differences, at least. In phishing, there is no knowledge or information about the victims ahead of time. There is the email is being sent blindly or randomly. However, in spear phishing, there are knowledge or information about the victims. The attacker has put some targeted information in the email that the attacker is sending, and that way these are different. Okay, the last question is this. We are given this code and we are asked to discuss. Okay, let's read it together. Assume that we have a program D. There is a program D that is able to analyze executable files to detect if they're clean or virus infected. So this D that you see here, it says if D. This D is that program that takes something and says, and takes an executable file and says if that executable file is infected or clean. That's for any program P if we run D of P. So that D helps for any executable. Here, for example, like P. The result is either true, which is infected, or false if the program is not infected. Now consider the following program at which infect executable is a module that scans memory for executable program and replicates itself in them. So this is the situation that now we are dealing with. Discuss under which circumstance D can or cannot correctly decide whether CV is a virus. Basically, CV is our virus here. And what CV is gonna do is that it's CV is aware of having D in our computer. And look at the code of CV. CV comes and here says if it checks if D is able to classify C as virus. If D is capable of classifying CV, in that case, CV, which is a virus, is not gonna do anything bad. It's basically like the situation that, let's say, for example, I'm driving and I see a cop, and I'm sure that I check and I make sure that he can see me, so I don't do anything wrong. I'm personally a bad person, but because of that cop close to me, I didn't do anything bad. This is what CV is checking. CV checks, the virus checks if the cop, the police, is capable of detecting CV or not. If yes, CV is not gonna do anything bad. Otherwise, he does a bad thing. So now the question is, what are the situation or what are the condition at which CV will be detected? What are the situation at which CV cannot be detected? Any thought on that?
So I thought this was asking, and I don't know if I'm on the right track or not, but I thought this was asking about the generations of antivirus software. Is that the right direction to go with this?
Yeah, that's correct. That's basically how CV tries to regenerate itself or kind of infect more and more executable. But the question is, under which circumstance this virus can be detected eventually at some point, or under which circumstances the virus CV cannot be detected? This is the question that we are now about to answer. So let me tell you this. So what this line says, what this line again, let's get back to that example. That example was good. I'm driving, I'm a malicious person, and I see a cop, I see a police machine, and I check if the police machine is able to see me. If I get to a conclusion that the police person is able to see me, I don't do anything, and I don't do anything bad. So in this case, the program CV, which is the virus, is calling D and is passing himself as a parameter to that D. So getting back to our example is like that. I'm the bad person and I see the cop. I park my car here and I go and and look at my car from the, for example, let's say, eyes of that police person. That basically means that I need to go and sit on his seat. So it means that I need to access that police machine. This is exactly the exact thing that here happens. The program CV is calling D. D is a security program like an antivirus. And in most cases, antiviruses cannot be called by user programs. If a user program calls antivirus, antivirus gives an alarm to the operating system and says, hey, someone, not you, someone else is calling me. This should be something wrong. No one other than our operating system should be calling me. So this is a situation that happens. And the answer to this question by all of these things said is there are two different situations. Number one, if operating system is being informed that CV is calling D, in that case, we can say D is doing bad thing. Like the situation that I go to the police car and the police immediately says, hey, you shouldn't come here. Why are you here? And I fail going there, so I will not be able to determine if the police sees me or not. So I do my bad thing, and then police catches me. So if the system identifies that CV called D, in that case, CV would have a difficult time, and CV will be catched. But if the system is not capable of catching CV calling D, CV calls D, CV will be aware of these capabilities and can decide to correctly either hide himself or not hide. So in that case, CV will never be caught. So the answer to this question again, two different things. Number one, operating system is being informed if D is called by CV. If yes, CV will be caught. Number two, operating system will not be informed D is called by CV. Under number two, CV will go forward and will not be caught.
Can you say part two again? You said the operating system is not being informed.
When when D is called by CV, in that case, CV, which is the virus, will be able to effectively hide himself and it will not be catched. So I have all of these things written. I have prepared a file, and I'll be sharing that with you on the Blackboard shortly. So if you have taken some notes, that's perfect. Otherwise, don't worry. I have all of the things written, and and I'll be sharing them with you, like I said. And there are, for example, for multiple choice or wherever which I gave you explanations. The explanations, of course, not that long, but the most important part of that explanations is also on the file as well.
Okay. Can you make it so that I can see what I submitted on Blackboard? Because some of these questions I don't remember what answer I chose.
Uh,
And I just want to see what I got wrong and what I.
I'm not gonna grade them because some of them are uh, mm, I I can probably for you I can take a screenshot of your multiple choices and send back to you.
Okay, that'll be helpful.
Yeah, I'll send them. I'll send a screenshot of your multiple choice and send them back to you.
Okay.
Okay, is there any other question from any of you?
I do have one more.
Yes, go ahead.
There a percent of questions that will come from all three lectures? Like most of the tests will be focused on lecture one, or most of it will be focused on lecture two?
It'll be a combination, but of course, lecture two, which was the last lecture, was the I would say is the longest, and proportionally it would cover more questions.
Okay. And did you say how many questions the exam will consist of?
I don't remember. It should be something around the same thing. Maybe three multiple choice or four multiple choices and three or four free response questions.
Oh, okay.
So
Dr.
it's not that.
Patugi, sorry, I came late. It was,
That is
working.
fine. Yeah, go ahead, Val.
I have a question. Will the questions be basically based on what you covered in your slides, or also or things that are outside of what you covered in your
No,
slides?
nothing out of the slides. Yeah,
I
thank you for
appreciate
asking that question. There is nothing out of the slides and what discussed in the videos. Nothing. Everything. You even don't have to go and read the entire book because book is wider than. Of course, I summarize it, and there are some areas that I feel they are unnecessary, especially given that our time is limited. You it would be a good practice to go and read the textbook. However, you even don't have to do that.
Appreciate that. Thank you.
Thank you. That was a good question.
Okay. If there's no more questions, I'm gonna wrap up. And like I said, the exams will be available to you starting from tomorrow, 8 a.m.
One more question, Dr. Patugi.
Mhm.
Did you said you're gonna put the answers on the blackboard?
Yes,
Is also are you gonna put this recording as well or not? So just
yes.
okay.
Immediately after this meeting, I download it, I put it on YouTube and put a link plus the solutions to the sample questions.
Thank you, sir.
Thank you, everybody. Have a great rest of the day.
Thank you. Bye.
Bye.
Bye-bye.